Hey guys, it's Mr. Bison here, and I am going to be doing an exam paper walkthrough for the 2020 series. Now, these were meant to be sat in the summer, they were sat in October for some private candidates. This is paper 2. I've also got a paper walkthrough for paper 1, and it is hard. This paper is really, really hard. These were the grade boundaries, and you can kind of see here that to get an A, you could still get about half marks, and to get A star, you could still drop about 30% of the marks. So please bear that in mind when you're going through these questions with me, because you're going to think, what? Some of these are absolutely crazy. And they are crazy hard. But don't worry, you can skip parts of it. Remember that exam strategy of just going straight to the bit that you can do and not worrying too much about the bits that you can't. But hopefully, I'll get you some of those extra marks. There are 16 questions in this paper. So this is how they think they'll start us off nicely with some stuff to do with the trapezium rule. So it says the table below shows corresponding values of x and y for y equals the square root of x over 1 plus x, and the values of y are given to 4 significant figures. Use the trapezium rule with all the values in the table to find an estimate for this. So basically just do the trapezium rule, giving your answer to 3 significant figures. So the trapezium rule is in the formula booklet, but I'm just going to go straight in, that we would say that the answer to this, using the trapezium rule, is going to be a half of the height, which is this gap that we've got here. So that's a half times 0.5. We then do the first plus the last, which is 0.5774 plus 0.8452 plus 2 lots of the ones that are in the middle. So that's 0.7071 plus 0.7746 plus 0.8165. And we're just going to type that all into the calculator and see what we get. So it is going to be a half multiplied by 0.5. And then in my brackets, I'm going to do 0.5774 plus 0.8452 plus 2 lots of the middle ones, which is 0.7071 plus 0.7746 plus 0.8165. Close off the brackets twice, press equals, and we have got here that they want it to 3 significant figures is 1.50 to 3 significant figures. Okay, so that's good for the first part, 3 easy marks there. And then it says, using your answer to part A, deduce an estimate to this thing. Well, let's see what the difference is. First of all, the limits are the same. The thing that's different is this one has a 9 and this one doesn't. So we need to try and make them look the same as each other. So for part B of the question, if I'm going to be doing 0.5 to 2.5 of this thing, if I take out a factor of a 9, you also have to take it out as a root. So it's like root 9 root x over 1 plus x dx. That root 9 is 3, so I can just put the 3 to the very front. And we've already done an estimate for this thing, haven't we? That was what we did in the first part of the question. The first part in that question was this thing, which is exactly what we've got here. So it's just going to be 3 multiplied by our previous estimate, which is 3 times 1.5, which is 4.50. That is our estimate for the next part that we've got there, okay? Part C of the question says, given that this thing is equal to 4.535 to 4 significant figures, comment on the accuracy of your answer to part B. So we said that it was 4.50, they said it was 4.535. So actually, they're really close to each other. When they're looking for a comment on the accuracy, I would say something like, our answer is very accurate. It is correct. And we can say what significant figures. It is correct to 2 significant figures. If our answer was to 2 significant figures, 4.5, that would be the same as this one to 4.5. Now, they accept loads of different things like this. I'll just tell you some of the things they accept. They would say it's high accuracy, it is a very good estimate, it is an underestimate but quite close, it is less than 1% out, it is accurate. These are the kinds of things that they would accept for this, okay? So you don't have to do what I've just done there, but they say that the answer is accurate. They're just looking for it being quite a sensible one there. Okay, so part two, they're already going with some things that are a bit unusual. Even so, part two, question two, they're already doing some quite unusual things, and this is the kind of stuff I think would have made people sort of panic. So let's just try and break this down. It's only question two, it shouldn't be too hard. It says, relative to a fixed origin, the points P, Q, and R have these position vectors respectively. P, Q, and R lie on a straight line, and Q is 1/3 of the way from P to R. So I just like to draw a sketch of this. So they're on a straight line. We've got P and R, and it says that Q is 1/3 of the way along this line. So I'm going to try and translate this into like a vector question before I even worry about what they're trying to show me. I think that to go from P to Q is the same as going from P to R, but just going 1/3 of the way along the line. So I've got that PQ is 1/3 of PR. Now, I know the standard thing is that if I'm doing the vector AB, you do the position vector of B minus the position vector of A. So I'm just going to do that and see if I end up with the thing that I want to have here. So I'm going to do Q minus P, second letter minus the first letter, equals 1/3 R minus P, the second letter minus the first letter. So that's Q minus P equals 1/3 R minus 1/3 P. And they want us to make Q the subject, so I'm just going to add P to the other side. So that's 1/3 R. Now minus 1/3 plus 1 is plus 2/3 P. So I'm now just going to factorize the right-hand side. I'll do 1/3 brackets R plus 2P. Sometimes I find when students aim for the thing that they're looking at, they don't really know how to get there. Just write down what the question is telling you, write something else down, and do things that you know, okay? I don't know how to get to this. What I do know is how to do this, and then, oh, look, it just seems to happen. So try not to aim for this too much. Use it when you're getting very close to the answer, but not at the very beginning. Okay, question 3. Given that this is true, show that this is true. Okay, well, this is just a log equations. So I think what we can do here is take this 2 that's outside the front and put it in as the power. So that's log of 4 minus x squared equals the log of 8 plus x. Now it's written like this. I actually think I can just ignore the logs because they've both got the same log that's at the beginning. So I can just say that 4 minus x squared is equal to x plus 8. I'm going to expand these brackets, which gives me 16 minus 8x plus x squared equals x plus 8. We're aiming for a quadratic that we've got here, so I'm going to keep the x squared on this side. I'll do minus 8x minus x, that's minus 9x, and I'll do the 16, take away the 8, which is 8, which is exactly the thing that they wanted. Then it says for part B, I write down the roots of the equation. Now, obviously you can use a calculator. I'll use this calculator for lots of it, but I'll be using the ClassWiz or the graphics calculator at the same time, which I'm not going to put on camera. So I'm going to be very lazy. Of course, I could factorize this, but I'll do 1, minus 9, and 8 as my coefficients. And very quickly, I can see that my two solutions are that x is equal to 8 and x is equal to 1. So that was just writing down the roots. And then for part 2 of this, part II, it says state which of the roots is not a solution, giving a reason for your answer. So the thing that we need to remember here is that you can't input negatives into a log. You can't input negatives into a log function. So this is fine, because if I put 8 in there and 1 in there, it'd be positive. But this one, if I put 8 in there, I would get negative. So 8 is not a solution, as 4 minus 8 is negative, and you cannot input negatives into logarithms. You can just write logs instead of logarithms. So the only solution is actually x equals 1. X equals 8 is not going to be a solution because you'd be inputting a negative. You can check on your calculator, it just won't work. Okay, so in the binomial expansion of a plus 2x to the power of 7, the coefficient of x to the power of 4 is this. Find the value of a. So if I'm going to try and do the one that is x to the power of 4, we have the power is 7, and we want to have that 4 ways. So we're going to do 7 choose 4 to get to that part. And we want there to be x to the power of 4. So that's going to come from my 2x to the power of 4. And that's also going to be multiplying by, remember that these bits, the powers of them need to add to 7. So it's going to be a cubed. So this 7 choose 4 is because there are 7 brackets and we want to pick the x, this term 4 times. So it's 7 choose 4. Now I can never remember where it is on this calculator. Okay, good, it's here. So I'm going to do the 7 choose 4. So that's 35. So this is going to be 35a cubed multiplied by 2x to the power of 4. So that's going to be a 2 to the power of 4 multiplied by 16x to the power of 4. Okay, so that's going to give me 35 times 16. That is 560 a cubed x to the power of 4. And now they've told me the coefficient of x to the power of 4 is this. So that must mean that 560 a cubed is 15,120. So I'll do 15,120 divided by 560, which is 27, and then I'll cube root it. And the cube root of 27 is 3. So unfortunately it's only 3 marks, but we've got that one there, which is 3. Okay, we are now moving on to, what's the next question that we've got here? Question 5. The curve with equation y equals 3 times 2 to the x meets the curve with this equation at the point P. Find the coordinates. Well, we know what they meet when it's simultaneous equations, so that means that 3 times 2 to the power of x has got to be equal to 15 minus 2 to the power of x plus 1. Now you can't take logarithms here because of this 15 that's getting in the way. So instead, I'm going to try and manipulate it to make it look like a pseudo-quadratic. That means I can take this 2 to the power of x plus 1. Remember, that means 2 to the power of x multiplied by 2 to the power of 1 because you add the powers. So this is 2 to the power of 1 multiplied by 2 to the power of x. I've just written those the other way around there. So I can add this to the other side so that I've got 5 lots of 2 to the power of x being equal to 15. I can now divide by 5 so that I get 3. And now at this stage, I can either write this as logarithms. I do everything with natural logarithms. So I'm going to say it's the ln of 2 to the power of x is the ln of 3. So I'll put the x outside the front. And then I'm going to do ln 3 divided by ln 2. Now this isn't exactly what they've got. I think in the mark scheme, what they actually write it as is the log base 2 of 3. But these two things are equivalent to each other, and they've said in the mark scheme that they would accept either. I just tend to do natural logarithms for everything. So I think what's hard to spot is that we're almost like treating this 2 to the power of x that we have here, we're almost treating it like a piece of algebra. Like this line that we've got here is like, I don't know, 3a equals 15 minus 2a, which is why we end up with 5a equals 15, a equals 3. That's kind of what's going on with this if it were written in like an algebraic kind of way. Well, it is in an algebraic way, but if I was doing it with like a substitution to make it easier to see. Okay, question 6, it says, given that this is equal to this, find the values of a, b, and c. You could do a method of combining these all to one thing and comparing it. There's lots of different ways. I'm probably just going to do polynomial division for this. So I'm going to do my x squared plus 8x minus 3. I'm going to divide that, horrible division sign I just did, by x plus 2. So x squared divided by x is just x. Now I'm going to take that x and multiply it by the x plus 2, which is going to give me x squared plus 2x. And then I'll subtract. They cancel, and that leaves me with just 6x. I'll pull down that minus 3 now, and I'm going to do the 6x minus 3, or the 6x divided by the x, which is just a plus 6. So I'm going to do the plus 6 multiplied by the x plus 2, which is 6x plus 12, and I'm going to very carefully subtract these. 6x take away 6x is nothing. Minus 3 minus 12 is minus 15. So this means that it can be written as, instead of the a value is going to be 1, because it's just this bit that we have here, that's x plus 6. And then this leftover bit, this remainder that we've got down here, is going to be where c is. That's the part that goes with the c bit. So it's going to be minus 15 over x plus 2. So the value of a is 1, the value of b is 6, and the value of c is minus 15. Okay, hence using algebraic integration, find the exact value of this, and I have unfortunately put that in the way. It wants to be in the form a plus b ln 2. So I'm going to actually just immediately rewrite this in the form that we have over here. So I'm integrating x plus 6 minus 15 over x plus 2 with respect to x, and it's got limits, so I can go straight in and say This is going to be a half x squared plus 6x, and this is just going to be minus 15 ln of x plus 2, and that's between 0 and 6. Now, this is actually easy, the integration. The thing that's going to be hard here is making it look like it's in the form a plus b ln 2, but we can do it. So I'm going to sub in 6. That's going to be a half times 6 squared. Well, 6 squared is 36, and a half of 36 is 18. Then I'm going to do 6 times 6, which is 36, and then I'm going to subtract 15 ln of 6 plus 2, which is 8. I'm then going to subtract a 0, and a plus 15 ln 2. 15 ln 2, because x is 0 that we've got here. So 18 plus 36, being very lazy, is 54. So we have 54 minus 15 ln 8 plus 15 ln 2. Okay, we really need it to be with ln 2's here. So let's see if I can adapt this one. Hopefully we recognize that 8 is 2 cubed. That's going to be a really useful fact. So I'm going to rewrite this as 15 ln of 2 cubed. And then what I can do with that 3 is I can pull it to the front. So 15 multiplied by 3 is 45. So the 54 I haven't wanted to change at all. I've now got minus 45 ln 2 plus 15 ln 2. Minus 45 plus 15 is minus 30. So we have 54 minus 30 ln 2 like this. Now you could always check that you've got this right. I'm not going to do it now, but you could literally type into your calculator that thing that we've got there. You could type in 54 minus 30 ln 2, and you should check that they are exactly the same thing. It won't give you this in an ln form, it will give it to you as a decimal, but you can compare it to the decimal, and all your calculators that you're using will have the feature where you can type in integration, okay? So let's have a look now at question number 7. Okay, it says figure 1 shows the sketch of a curve with this equation, and great, it seems like it's going to be quite easy. We're just going to show that it differentiates to this. But it's not that simple, I don't think. Let's actually just take this. So it's y equals, I'm going to write it down at the bottom so that I can see it, 4x squared plus x. Y equals 4x squared plus x over the square root of x. Over 2 square root of x, sorry. Minus 4 ln x. So before I differentiate it, I don't want to do the quotient rule on this. I actually think I can just split the numerator and tidy it up a bit. So that's 4x squared over 2 root x, or 2x to the half, plus x over 2x to the half, minus 4 ln x. So simplifying this first bit, that we've got the 4 and the 2 are going to divide just to a 2, and 2 take away a half is 3 over 2. Now, sometimes people put the 2 at the top, but it actually stays in the denominator, because it's in the denominator fundamentally. This is x to the power of 1 divided by x to the power of a half, which is just x to the power of a half. And then we have minus 4 ln x. So now we can just differentiate this. So I'm going to pull the power down and reduce the power by 1. I'm going to pull the power down and reduce the power by 1. And when you differentiate ln x, you just get 1 over x. So it just goes to 4 over x. So when I tidy this up, the 2 times 3 over 2 is just 3. So I get 3x to the half plus a quarter x to the minus a half minus 4 over x. Now this is where we've done the differentiation, but they want it to look something like this. The main thing is that theirs is a single fraction, whereas ours are 3 separate terms. So we're going to try and create a single fraction. At the moment, I need to actually make it look like a fraction. So I have 3x to the half, then I have plus 1 over 4x to the half, because that power of minus a half sends it down into the denominator. And then we have minus 4 over x. Now I'm going to change them to the square root signs at the end, I think. For now, I'm quite happy with how they're looking like this. So I need to get a common denominator. I think the common denominator is going to be, oh, maybe I shouldn't have done that actually. Let me think, 4x root x. Yeah, I'm going to just go with a simple common denominator. I'm going to just go with my 4x to begin with, because I think I can make them all have that common denominator. I might need to change it afterwards. So that means this one the first one, if I need to make it have a 4x on the bottom, I need to also multiply the top by 4x. So that is going to be 12x to the half, and it's also multiplied by an x. This one needs to be multiplied to make it become a 4x. I'm going to multiply the top by x to the half. And then this one, I just need to multiply the top by 4 so that it has 4x. So I can combine this and say that this is 12x. This is why I'm now going to go into the square root signs. I have 12 root x, x. I'm going to do this on the next line so I have enough space. So this is 12 root x, x plus root x minus 16 all over 4x. Let's see if we're getting there. Okay, it kind of looks like we're getting there. We've got the 12, the 16. The only difference is that I went with 4x on the denominator, and actually they've also got an extra root x there. So I'm going to multiply the top and bottom by root x to create that. So I'm going to multiply by root x here and root x here, which is going to give me, well, the square root of x times the square root of x is x, times it by another x is x squared. So we get 12x squared. Root x times root x is just x, and 16 times root x is 16 root x. And on the denominator, that is 4x root x. Is that what they've got? Let's just check. 12x squared plus x minus 16 root x. 12x squared plus x minus 16 root x over 4x root x. Quite a lot of manipulation there. I'm interested to see how many marks that they would actually give you for that bit. So if you got to that differentiation part, you only got 2 marks, I think. No, 3 marks for doing the differentiation. The 4th mark is for combining it all together. So interestingly, all of this bit down here was just worth 1 mark. So really in terms of like time, that might be worth like a moment to kind of sacrifice that, because, you know, like I said at the beginning, the grade boundaries are kind of low because these exams are so hard. This question is not finished. So it says the point P is the minimum turning point. If it's a minimum turning point, we know that dy by dx is going to be equal to 0, right? And so we want to find out what the x coordinate, so it says show that the x coordinate is a solution of this thing. Now it says x equals something. We're not actually, it's trying to set us up for an iterative formula that we've got in part C of the question. Now these are notoriously really difficult to come up with yourself. So what is a good idea is actually to take the thing that they've given you and to work backwards. If you work backwards and you end up with something to do with dy by dx, then you're in a much, much better position. And they actually say that in the notes. They say something that, I'm just going to double check to see, so I read it out to you correctly. It says in part B, yeah, alternative, working backwards. At the end, you just need to say, so I've worked backwards and it worked. Okay, so we're trying to find out this point here. So dy by dx is equal to 0. So because dy by dx is equal to 0, that means we just worry about the numerator. So we want 12x squared plus x minus 16, I'm going to go with x to the half, is equal to 0. And I'm actually going to work on the thing that they've got backwards, and then we can sort of finish it. So the thing that they have written down is 4 over 3 minus the square root of x over 12. So they've written down 4 over 3 minus the square root of x over 12 to the power of 2 over 3. And they've said that that thing is equal to x. And the thing that we want to show that it's the same as is here. So I'm going to work backwards, and I'm just going to see if I can make them look the same. So I'm going to do both sides to the power of 3 over 2. If I do the opposite of 2, the inverse of 2 over 3, which is 3 over 2, or the reciprocal, I get x to the power of 3 over 2 is just going to be 4 over 3 minus the square root of x over 12. Remember, this is the same as the square root of x. If I times everything by 12, I get 12x to the 3 over 2. 4 over 3 times 12 is 16. And then I get the square root of x here. So you can see it's really starting to look similar to this. The only difference is this one is 3 over 2 and this one is squared. So everything now needs to be multiplied by the square root of x. Or we could say everything needs to be multiplied by x to the half. So that gives me 12x squared, which is 16x to the half. And square root of x times x to the half is just x. So it looks really similar to this thing at the top. So that's 12x squared plus x minus 16x to the half equals 0. So you can say, by working backwards, I've shown it's true. But if you wanted to, you could then literally write these steps in reverse underneath this. So what I mean by that is you could rearrange it and say, okay, well, 12x squared is equal to 16x to the half minus x. That's this line here. Then I could divide by x to the half. So that's x to the 3 over 2 equals 16 minus the square root of x. Then I could divide by 12. And then I could do it to the power of 2 over 3. And I've shown it's true. So if you work backwards, you need to have a little statement, or you can just recopy it, but literally just write the sentences backwards for this. I hate these ones. I think they're so hard. I always work backwards. You're not going to do it if you just try and manipulate it to make it look like that. So it says, use the iteration formula with x1 equals 2 to find the value of x2 to 5 decimal places, and then it to 5 decimal places. It doesn't need to prove what the x coordinate is to 5 decimal places. You can just keep pressing equals and get there. So x1 is equal to 2. So I'm going to use this formula that we've got for part C of the question, which is that xn plus 1 is 4 over 3 minus the square root of x over 12 to the power of 2 over 3, and x1 is equal to 2. So x2 is going to be equal to 4 over 3 minus the square root of 2 over 12 to the power of 2 over 3. So if you couldn't do part A or B, you can still do part C and get these marks. So I'm going to set this up slightly differently on my calculator. I'm going to press 2 equals, and I'm going to store that as the answer button. Okay, so that's now my answer button. I'm now going to write the iterative formula, which is 4 over 3 minus the, let's put this as a fraction, the square root of, not the cube root, the square root of the answer. I'm kind of copying out this formula that I've got right here, but I'm putting answer instead of x over 12 to the power of 2 over 3. So it's given me the first one for x2, and it wanted it to 5 decimal places, which is 1.13894. 1.13894. And then it wants it to be correct to 5 decimal places. So you can literally keep just pressing, because I just think it wants it correct to 5 decimal places. Yeah, find the x coordinate of P, and say the x coord of P. If you just keep pressing equals, you'll see how it slowly starts changing. If you just press it a few times, you'll see it's not really going to change anymore. So the x coordinate of P to 5 decimal places, there's no method mark for this at all, so you can just write this down. It's 1.15650. It didn't change as many times as I press equals, so that's it correct to 5 decimal places. Okay, I don't know why I'm trying to do this in one video, but I am, so it's going to take a long time. But I've got the little timestamps on the bottom, hopefully to help you as well. So it says a curve has equation y equals f of x, and they've told us some things about the curve. We're going to try and find out what the f of x equation is. So the first thing they've told me is that f dash x is 6x squared plus ax minus 23. Now, because I'm trying to find out what f of x is, to go from this to this, we integrate. So I'm going to increase the power by 1, and I'm going to do 6 divided by that new power. I'm going to increase the power by 1, and I'm going to divide by that new power, and I'm going to add the x on there and add on c. So that means that f of x is 2x cubed plus a over 2x squared minus 23x plus c. So I've dealt with that first bullet point. It then says that the y-intercept is minus 12. So this means that when x equals 0, f of x is minus 12, or I could have just written that f of 0 is minus 12. So I'm going to use that. So f of 0 is minus 12, so I'm going to say that minus 12 is when you sub 0 in, so that would be 0 plus 0 minus 0 plus c. So c is minus 12. Okay, so I've dealt with that one. It then says that x plus 4 is a factor of f of x. So if x plus 4 is a factor, then that means that f of minus 4 is equal to 0. That's the factor theorem. So f of minus 4 is equal to 0. So I can go back to this one here, and I can say that 0 is equal to 2 minus 4 cubed. So I'm subbing in the x as minus 4, plus a over 2. That's an a, not a 9. Let's make it look more like an a. Plus a over 2 minus 4 squared, minus 23 times minus 4 plus c, which is minus 12. So that is 0 equals 2 times negative 4 cubed. 4 cubed is, I think, negative 64. So 4 to the power of 3 is 64. So yeah, that's 2 times negative 64. That's minus 128. Plus negative 4 squared is 16. And 16 times a over 2 is 8a. I've then got 23 times 4, which is 92, so that's plus 92, and then that's minus 12. So if I put it all on the other side, that's 128 minus 92 plus 12 is equal to 8a. So I'm going to add them up and then divide it by 8. So I'll do 128 minus 92 plus 12 divided by 8, and so a is equal to 6. Now that's not the end of the question, because they said find in its simplest form f of x. So f of x is equal to, going back to the one that I've put the star by that's up here, 2x cubed plus a half a, which is 3x squared, minus 23x minus 12. And that's what f of x is. And that's in its simplest form. We don't need to do any factorising. They accept it in factorised form, but we definitely don't need to have it in its factorised form to be able to get that. Okay? So we are now going to move on to question 9, only just halfway through the paper. It says a quantity of ethanol was heated until it reached boiling point. The temperature, theta degrees, t seconds after heating began, is modelled by this equation, where a and b are positive constants. So you can see that power is minus 0.07 to the power of t. Given that the initial temperature was 18 degrees, that means when the time was 0, the temperature was 18. After 10 seconds, the temperature was 44. Find a complete equation giving the values of a and b to 3 significant figures. So actually this one's kind of easy. You're going to see why it's easy in a second. So I'm going to put these first two things into the equation. That is that 18 equals a minus b e to the 0, which is just 18 equals a minus b, because e to the 0 is 1. Now the second one that I've got is that theta, which is 44, equals a minus b e to the power of minus 0.07 multiplied by t, which is 10, which is minus 0.7. Now you might not see it, but this and this are actually just linear simultaneous equations. If I write them in a slightly different way, if I write it as a minus b equals 18, and a minus e to the minus 0.7 b equals 18, e to the minus 0.7 is just a number. So you can actually go to your simultaneous equations and you can type in for your simultaneous equation solver, which I'm going to do on my calculator. You can type in with two unknowns. Why is it crashing? There we go. Simultaneous equation with two unknowns. You can type in for this first equation that the coefficients are 1, minus 1, and then for the last part 18. And then here you can type in 1. Then you can type in minus e, so you're going to do minus e to the power of minus 0.7. I'm just going to put brackets around the minus 0.7. That should come up as like minus 0.496. Oh, it shouldn't say 18 over there, should it? It should say 44, and I'm going to type 44 in as well. That gives me my values automatically for A. A is going to be to 3 significant figures, 69.6, and B is 51.6. You can literally just see that on the calculator in the way that it's given. Now it wants it to say a complete equation, so you just need to put it all back together again. That is that theta is equal to 69.6 minus 51.6 e to the minus 0.07 t. So part B of the question says that ethanol has a boiling point of approximately 78 degrees. Use this information to evaluate the model. So they said that they were heating it until it reached boiling point. but our equation is this. So our model actually has a limit at the top. Hopefully you've spotted this is the maximum thing that can be, because you're always going to be taking something away from it. So our model has an upper limit of 69.6 degrees. That's where you get the first mark for this. So you can say the model is therefore not appropriate as this is much lower than the boiling point of 78, as this is much lower than the boiling point of 78 degrees centigrade. So the kinds of things that they would accept for this is like the model has an upper limit of 69.6, it's not appropriate. The minimum things that they would accept for this is they say the model is not appropriate as 69.6 is much lower than 78. So you don't even have to talk about the boiling points. That's the absolute minimum that they would accept. The model is not appropriate as 69.6 is much lower than 78, but they really do need you to mention that number, 69.6. Okay, question 10. This exam paper is so full on. It's like every question is tough. It says, show that cos 3a is equal to this. Okay, you may have seen this before, but it's quite rare. People don't often look at this. 3a is the same as 2a plus a. So I'm going to do the addition formula for this. That is going to be cos 2a cos a minus sine 2a sine a. Now I'm going to use my double angle formulae. I know that cos 2a is 2 cos squared a minus 1. The reason I've picked this one is because you'll notice the right hand side is all in terms of cos. There's 3 different versions of this double angle formula. Make sure you pick the one that's with cos. And we know that sine 2a is 2 sine a cos a. The reason I'm trying to make them all be with a is it's just a here, whereas this is 2a and this is 2a. I'm trying to reduce it all down so that it is a. So cos 2a, that's 2 cos squared a minus 1 multiplied by cos a, minus 2 sine a cos a, that's the sine 2a, but there's also a sine a there as well. So I'm going to expand the brackets on this first section, which is 2 cos cubed a minus cos a, and just simplifying this, I get 2 cos a multiplied by these two, which is sine squared a. Now the issue is there's nothing to do with sine here, but there is a sine squared here. So also remind yourself that sine squared is 1 minus cos squared. So I can now repeat, I can do some more organising of the second part, which is minus 2 cos a multiplied by 1 minus cos squared a. Nearly there. 2 cos cubed a minus cos a minus 2 cos a, and that will become a plus because of the two negatives, plus 2 cos cubed a. The 2 and the 2 gives you the 4 cos cubed a, and then you've got minus 3 cos a, which is what they wanted us to show here. I mean, this is really tough stuff. Hence, solve for this weird range that we've got here. 1 minus cos 3x equals sine squared x. So that was part A. We're now going to solve 1 minus cos 3x equals sine squared x. Now they always do this. Whatever you do in the first part of the question, because it says the word hence, you're going to use that. So we know that cos 3x we can replace. Cos 3x can be replaced with a version of this. 4 cos cubed x minus 3 cos x. And I don't like equations that's got a mixture of sine and cos, so I'm going to change the sine squared to 1 minus cos squared x. Right, let's see what happens here. So I get 1 minus 4 cos cubed x plus 3 cos x equals 1 minus cos squared x. Okay, great. This 1 was starting to worry me, but actually there's a 1 on both sides, so I can subtract it from both sides. And I can also now put everything onto the right-hand side so that I get 4 cos cubed x minus cos squared x minus 3 cos x. Now you can actually divide everything here by cos x. If you divide everything by cos x though, remember that means that cos x equals 0 is a solution. So when I divide this by cos x, I get 4 cos squared x. When I divide this by, I get cos x, and when I divide this, I get minus 3. So when cos x equals 0, this is still a solution. Cos x is equal to 0. This is how lazy I'm being right now. I should know this, and people would be mad at me for doing this. But the inverse cos of 0 is 90. There's not going to be any other solutions that between 180, or is there? Let me just quickly think. Cos starts here. Yeah, it's 90 and it's also minus 90. So we could also put minus 90 in for this one as well. So there are two solutions. You've got 90 and you could also do 360 minus that, blah, blah, blah. So x is 90 and minus 90. It's just with the graph, it goes to 90 and minus 90 for the cos graph like this, okay? Now we need to solve this thing, which looks a bit like a quadratic. So I'm going to pretend that it's a quadratic and find out what cos x is equal to by putting this on my calculator with the coefficients for a polynomial with 4, minus 1 and minus 3. So when I go to my polynomial equation solver, I'm going to put in the coefficients 4, minus 1 and minus 3. And that tells me that either cos x is equal to 1 or cos x is equal to minus 3/4. Now, if cos x is equal to 1, thinking about the cos graph again, it is like this, and it's only between minus 90 and 180, so the only place is when x is equal to 0 degrees. So far, we've got 90, minus 90, and 0. We just need to do the last one, which is to find the inverse cos of minus 3/4 or minus 0.75. So I'm going to do the inverse cos of minus 0.75. We're in degrees mode, which is what we want to be, and let's see what it wants the answers to be. It doesn't say, so I'm just going to give it to one decimal place, 138.6. So I'm going to say that x is equal to 138.6. Now I better check if there's any other solutions that would be inside that range. So for cos, you can also take that answer, you can do 360 minus the answer, that's not inside the range. If I subtract 360 from it as well, that is also not inside the range. So the only ones that we have for this are the ones that I've highlighted in yellow, and you just want to make that clear that those are your answers. So we'd say that x is minus 90, 0, 90, or 138.6 degrees. And you can use the solve feature on your calculator to check that you've got all of those correct as well. Such a hard question. I feel like I'm saying that about every single question, and I think I'm about to say it again for this one. So it says here that we've got a sketch of this graph. The vertex of the graph is at the point P. Find the coordinates of P. Okay, well, finally something that's easy. We want this to be when it's a minimum for P that we've got here. It's a minimum when this thing is 0, so that means that x is minus 4, and also that means that the y coordinate is minus 5. Now if you have a graphics calculator, you could literally type that in on the graphics calculator, and you would see that the coordinates of P are minus 4, minus 5. So for part A of the question, P is minus 4, minus 5. Now, part B says solve the equation 3x plus 40 is equal to basically the graph that we've got there. Now, you'll have seen when I've taught this, if you've watched any of my videos before, you want to sketch this and put 3x plus 40 onto the graph. But to be honest, I don't know if the sketch is even going to help us. Is it going to be 3x plus 40 up here and it's crossing both of them? Is it only going to be 3x plus 40 and crossing one of them? Is it just going to be crossing this one? It's so hard to know. So we're going to try a slightly different technique for this. We're going to solve the equation in both ways and see which of the solutions are valid. So I'm going to solve, first of all, the equation that 3x plus 40 is just a normal version, the positive version of this. So this is GCSE kind of stuff. So that's 2x plus 8 minus 5. That's plus 3. I'm going to subtract the x from both sides so that I get x plus 40, the 2x from both sides. And then I'm going to subtract the 40, so I get x is equal to minus 37. Now I'm just going to check that it's true. So for the left-hand side, it would be 3 times minus 37. So I'll do 3 times minus 37 plus 40. The left-hand side is minus 71. If I do the right-hand side, I'm going to do the minus 37. Minus 37, this is the part that's inside the brackets that I'm doing here, plus 4. Now, because it's got the modulus signs around it, I'm going to negate that answer so that it's positive. I'm going to times that by 2, and then I'll take away 5, and I get 61. So because the left-hand side is not equal to the right-hand side here, this means that x isn't equal to minus 37. It means that this is actually not a solution. So if you had a graphics calculator, again, you could just plot this and you would have seen that we're not going to be doing it with the positive version. That doesn't work. So instead, we're going to be doing it with the negated version, which means I can do this version instead. This is definitely going to give me a solution. So I'll do 3x plus 40 equals minus 2x, minus 8 minus 5 is minus 13. So that's 5x equals minus 53. So x is minus 53 over 5. So I'm just going to do 53 over 5. X is minus 10.6. So it was actually only intersecting with this branch that we had here. So when we drew the graph, it would be something that was only intersecting with that one. It doesn't intersect with the original part that we have on the right hand side. It doesn't intersect with that one. Great, there's more. A line L has the equation y equals ax, where a is a constant. Given that it intersects it at least once, find the range of possible values of a. Writing your answer in set notation. Excellent, that's what we wanted as well. So y equals ax is literally just going to be a graph that goes through the origin with some kind of gradient, okay? What we're going to do is think about how we could make this one have no solutions. If we, instead of doing it at least once, let's instead think about what about if there were no solutions, and then we can use that to help us problem solve. Well, there'd be no solutions if I drew this line. I'll do it in a red colour. If it were parallel to this one. If it were parallel, there would definitely be no solutions. And the gradient of this line, just by looking at this thing that we've got here, is clearly 2x. Okay, so the gradient is 2. So I'm just going to write down, if a was equal to 2, there are no solutions. Now we also could do it, let's do it in a slightly different colour, let's do it in a black. If it went through P, like this, not like that because it's not very well drawn at all. That's meant to go through P and the origin, okay? Not having a good day with this iPad. That would where it would be 1 point. If we made the gradient of that line any shallower, it would intersect in 2 points. So in this middle section in between these two lines here, it would have no intersections at all. So let's try and figure out what happens when y equals ax goes through the point P, which is minus 4, minus 5. I think this is C, is it? Yep. So if the line y equals ax goes through the point P, which is minus 4, minus 5, y is equal to minus 5, x is equal to minus 4, which means that a is equal to 5 over 4. So there would be no solutions if a was equal to 2, and if a was sort of going between here and here. So that means there are no solutions if a is between 5 over 4 and 2. So because we want there to be at least one solution, we're going to do the opposite way around of that. We're going to say that either a could be, instead of the inside region, we'll say the outside region. We'll say that a could be less than 5 over 4, or, I'm just going to double check I've put this all correct. Yeah, a could be less than, or it could be equal to 5 over 4, because if it was equal to 5 over 4, it's where it passes through this point P, so it's allowed to be equal to 5 over 4, or a such that a has to be, instead of being less than 2 over here, we're saying that a is greater than 2. Because if we made the gradient steeper than this red line, it's going to start crossing with this one. If we made the gradient shallower than 5 over 4, it's going to start crossing through P and these other ones that we've got here. Very, 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 very hard. And the fact they just decided to be like, oh great, let's just put set notation in there as well. Okay, question 12. Feels like this exam is never ending, and then we get this other evil question coming up too. It says the curve shown in figure 3 has parametric equations x equals sine t and y equals 5 sine 2t. The region R, shown shaded in figure 3, is bounded by the curve in the x-axis. Show that the area of R is given by this thing that we have got here. Okay, so to begin with, I think we need to know what this x limit is going to be. I think that's going to be quite important. That x limit is when y is equal to 0. This part that we've got here is when y is equal to 0. In fact, actually, we might not do that. This might just be the answer. I think when x is equal to 0, we get 6 sine t. Do we want x to be equal to 0? No, we want y to be equal to 0. My mistake. For that bit, we want y to be equal to 0, which means that 5 sine 2t is 0. Sine 2t is 0, which means that sine 2t is equal to 0 when it's either 0 or pi. So that means that t is 0 or pi over 2. So over here, t is equal to 0, and over here, t is equal to pi over 2. We could find out what the x coordinate is there. The x coordinate is 6 sine pi over 2, so the x coordinate at this place is that x is equal to 6. But I think we've already got the t limits, which are the 0 and pi over 2. So for parametric integration, you do the integral, normally you do the integral of y dx. But because it's parametric, we're going to have to do y dx dt. Hopefully you can see these are equivalent because the dt's sort of cancel each other out. So in this equation, we've said that y is equal to 5 sine 2t and x is 6 sine t. So I'm going to find out what dx dt is by differentiating it. Sine goes to cos, so it's 6 cos t. And so we can say that the limits are between 0 and pi over 2. So to get that, we do actually have to have shown this up here, that we were trying to say when y equals 0, t is these things that we've got here. And then we're going to have a think about the inside part of this. So y is 5 sine 2t, and x is 6 cos t. Sorry, dx dt is 6 cos t, and that's being integrated with respect to t. Okay, so we don't have the 60, we've got the 30, but it looks like there's no double angles. It looks like everything is in sine and cos. So we're going to have between 0 and pi over 2. The 5 and the 6 is 30. Now sine 2t is 2 sine t cos t, that's the double angle formula, and we're still multiplying it by that cos t that we've got there. So between 0 and pi over 2, 30 times 2, that's 60 sine t cos squared t dt. Yep, there it is, 60 sine t cos squared t dt. Hence, show by algebraic integration that the area is exactly 20. Okay, so we're actually just going to do the integration part of this. So I am going to immediately see that this is an example of the reverse chain rule. Okay, that's because the sine is the derivative of the cos part that we've got here. Now, because it's a cos squared, that means that it is going to go to, the area R is going to go to a cos cubed t. I've increased it from a cos squared to a cos cubed. Now, normally when you differentiate cos cubed, let's just quickly do a bit of differentiation over here. This is cos t cubed. It would go to 3 cos squared t, and then the derivative of cos is sine. So we don't want it to have a 3, we want it to have a 60, which means that there needs to be a 20, because 3 times 20 is 60. And that's going to go between 0 and pi over 2. So that's going to be 20 cos cubed pi over 2 minus 20 cos cubed 0. And when you sub in cos of pi over 2, we get 0. So this is 0 minus 20. So, oh no, hang on, cos of 0 is 1, so that is actually minus 20. I just want to double check and see that that's okay. So we got negative for the area there. Oh no, I forgot, when you integrate this, silly me, this actually differentiates to this, right? When you differentiate cos t cubed, you get cos squared t, but the derivative of cos is minus sine. So because it's a minus, there also needs to be the minus here, which means this is a minus and this is a plus. So we do get the area of 20. My mistake there, I integrated this incorrectly. When you integrate this, it should have a negative, because when you differentiate cos, you get a minus sign, and we needed to counteract that negative. So the area is equal to exactly 20. Okay, part C looks very, very unusual. I haven't seen anything like this before. It says part of the curve is used to model the profile of a small dam, shown in figure 4. using the model and given that x and y are in meters, the vertical wall of the dam is 4.2 meters high. And it says there is a horizontal walkway of width mn along the top of the dam. Calculate the width of it. So we actually know something about m and n, and we know what their y coordinates are because they've told us that it's 4.2. So we know for m and n that the y coordinates are 4.2. We're going to try and find out what the x coordinates are. So I'm going to use this thing that I've got here. 5 sine 2t is equal to 4.2. So 5 sine 2t is 4.2, which means that sine 2t is 4.2 over 5, which is 0.84. So I'm going to find out what 2t is by doing the inverse sine of 0.84. We need to be in radians here, so I'm just going to switch to radians. The inverse sine of 0.84, that's 0.9972, blah, blah, blah. Now for sine, there are two solutions. You can have that solution and 180 minus that, which is pi minus the answer. So the other solution is 2.1443. So the values of t are going to be half of those. So if I just quickly half the previous one that I had, so I'm going to do that divided by 2. My values of t are 0.4986, blah, blah, blah. And if I half the other one, so I'm just going to quickly times that by 2 and do pi minus the answer. And I'll half that one. I get 1.0721, blah, 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 like this. So we've now got what the values of t are in these two particular places. We've got this t value and this t value, which was 0.4986 and 1.0721. So all I need to do is find out the x coordinates. And to find out the x coordinates, I'm going to use this, which is 6 sine t. So the x coordinate is going to be 6 sine t. So we've already got that the y coordinate for one of them, for both of them, is 4.2. We're going to find out what the x coordinates are. So I'm going to take these two values of t and I'm going to substitute them into this, and hopefully we're going to get the right answer. So I've already got that one stored in my calculator, so I'm going to use that one. 6 sine of the answer, that's 5.269. Okay, so one of them will be 5.269. And then the other one that we've got will be if I do the 0.4986. So I'm going to do 6 sine of 0.4986, which is 2.869. So the other one is 2.869, meaning this number is 2.869, and the other one was, so many numbers, 5.269. 5.269. So the width of this walkway between these two things here is these two numbers, the gap between them. So I'm just going to subtract them to find the width of the walkway. Hence, the width of the walkway is equal to 5.269 minus 2.869. So I'll do 5.269 minus the answer, which is should we say 2.40 meters to 3 significant figures. I'm just going to double check I've got that right, so I'm not sending you down the wrong way. Yes, we got 2.40 meters. Is that correct to 3 significant figures? I mean, it's just hard. It's hard, it's confusing, it's unusual. You just need to make sure you're getting the marks that you definitely can. Okay, another unpleasant question. So it says here that the function g is defined by this, where k is a constant, and we can definitely get this one mark here. It says deduce the value of k. Now remember, you're never allowed to divide by 0. That's why they put this in. So let's just pretend that we are dividing by 0. Let's say ln x minus 2 is equal to 0. That means, I don't know why they've got the brackets around the x, ln x is equal to 2, which means that x would be equal to e squared. So k is not allowed to be, x is not allowed to be equal to e squared. So that means that k is e squared in this case. It then wants us to prove that the derivative, the gradient function, is greater than 0 for all values of x in the domain. This is the domain that we've got here. So I'm going to take g of x and I'm going to differentiate it. So g of x is 3 ln x, I'm not going to bother with their brackets, minus 7 over ln x minus 2. Yep, it is the quotient rule. So u is 3 ln x minus 7 and v is ln x minus 2. When you differentiate 3 ln x, you get 3 over x, and when you differentiate ln x, you get 1 over x. Obviously the 7 and the 2 don't differentiate to anything. So when you do the quotient rule, you do those two, subtract those two, and then you divide it by v squared at the end. So g dash of x is these two multiplied, which is 3 over x brackets ln x minus 2, subtract 1 over x multiplied by 3 ln x minus 7, all divided by ln x minus 2 squared. It's just not a very nice looking derivative that we've got here. So we'll see if we can do a bit of tidying up and see what happens with this. So in the numerator, when I expand the brackets, I get 3 over x ln x minus 6 over x. I then get minus 3 over x ln x plus 7 over x, all divided by ln x minus 2 squared. Thankfully, this and this have cancelled. And what I get left with on the numerator, I've got 7 over x minus 6 over x. That's just going to be 1 over x. So I get 1 over x over ln of x minus 2 all squared. I don't really like the 1 over x in there, so I'm going to multiply the top by x and the bottom by x, and I get 1 over x brackets ln x minus 2 squared. That is just to find out what the first derivative is. We now want to try and show that it is greater than 0 for all values of x in the domain of G. Now the domain is that x is greater than 0. So we know here that x is greater than 0, and we want to show that g of x is greater than 0. I'm going to put brackets because that's what we're trying to show. Well, we know that this is greater than 0. So if this is greater than 0, then overall it must be greater than 0. So I'm going to say here that ln x minus 2 squared must be greater than 0 as it is squared, and we know that x is not allowed to be equal to e squared, because if it was e squared you'd get something being 0. So that's why it's greater than 0, not greater than or equal to 0. As x is greater than 0 and ln x minus 2 squared is greater than 0, then g of x is greater than 0 for the domain. Okay, because if that's positive and that's positive, the overall thing has to be positive as well. And when you thought that was hard enough, we've now got another part of the question. Find the range of values of a for which g of a is greater than 0. In other words, when is this greater than 0? So I'm going to rewrite it with g of a, and then I want to make it greater than 0. So let me just quickly copy it out for part C of the question. So g of a is going to be 3 ln a minus 7, 3 ln a minus 7 over ln a minus 2. Now, because I want this overall thing to be greater than 0, there are a couple of ways where this can occur. The only way where it's going to be positive, so g of a is positive if 3 ln a minus 7 is positive and ln a minus 2 is positive. Or we could say that it's positive if 3 ln a minus 7 is negative and ln a minus 2 is negative. Because if they're both positive, obviously you have a positive divided by a positive, so it's going to be positive. But if they're both negative, it looks kind of weird when you do it like that. If they're both negative, it is still going to be a positive thing overall. That's why I'm investigating these two scenarios that we've got here. So for the first part that we've got, this section that we have here, I'm just going to solve those inequalities. So 3 ln A must be greater than 7. So ln A must be greater than 7 over 3, which means that A must be greater than e to the 7 over 3. The second one is that ln A must be greater than 2, which means that A must be greater than e squared. So both of these things need to be true. Now let's just see which one is bigger. You can probably tell which one's bigger because 7 over 3 is obviously bigger than 2. But if I do e to the 7 over 3 and I do e squared, you'll see that 7 over 3 is bigger. So for them both to be true, it must be that A has to be greater than 7 over 3. Now we're going to investigate this one, which I'll do in black. It's actually going to give us the same equations, apart from it's going to tell us that A has got to be less than this, and A has got to be less than e squared. So the other thing is that A has got to be less than e squared, because remember e squared is smaller than this. But because it's logarithms, you also need to make sure that you say that A cannot be negative, so A has got to be in between 0 and e squared, or A has got to be greater than 7 over 3. And if you wanted to put it in set notation, you can, but we've got this is my answer, and this is my answer to this. The range of values for A are those two range of values that we've got here. You could put it in set notation if you wanted to. They're not looking for set notation, but you could write it in that way if you wanted to. Okay, we have got 14, 15, and 16 to go. Jesus, this one's also tough. I actually can't believe they gave this after the pandemic that people went through. This is mad, this paper. Okay, so a circle C with radius r lies only in the first quadrant, and it touches the x-axis and the y-axis. So I'm going to draw a sketch because this is going to help us actually proceed with this question. So there's a circle that only lies in this first quadrant, and it touches both the x-axis and the y-axis. So it looks something like this. Now we actually know something about this circle. We can come up with its equation. There is the center of the circle. We know what the equation of this is because this distance is the radius and this distance is the radius, which means the center is radius, radius. So I can come up with an equation of this circle. It's x minus r, because that's the x coordinate of the center, plus y minus r, because that's the y coordinate of the center, is equal to the radius squared. Then it says that the line L has equation 2x plus y equals 12. Show that the x coordinates of the point of intersection, that means simultaneous equations, satisfy this mad looking equation that we've got here. So I'm going to do simultaneous equations with 2x plus y equals 12 and this one, and because they want the x coordinate, I'm going to make y the subject. So I'm going to do 12 minus 2x, and I'm going to take that and I'm going to substitute that in there. So I have x minus r squared plus 12 minus 2x minus r squared equals r squared. That's x squared minus 2rx plus r squared. Now I'm going to do a little bit of working out down here that's going to help me to do this thing nice and quick. So it's 12 minus 2x minus r, 12 minus 2x minus r. I'm just going to do a quick grid method to help me multiply this out squared. So 12, 12, 144, minus 24x and minus 24x, plus 4x squared, minus 12r and minus 12r, plus 2rx, plus 2rx, and plus r squared. So this bracket is going to go to 144 minus 48x, then we have minus 24r, plus 4x squared, plus 4rx, plus r squared, and that's still equal to the r squared that we had that was from the other side. I mean, this is mad. I was doing a question like this with year 12 recently, and we were shocked. So we now need to do a bit of tidying up. First of all, that r squared and that r squared cancel. Let's see how similar we are to what they've got. They've got a 5x squared. Do we have a 5x squared? Let's check these things off. x squared plus 4x squared. Great, we have a 5x squared. Now we're going to look for, do we have this 2rx? Okay, well, we have 4rx minus 2rx. Great, that is plus 2rx. And then we've got minus 48x. So I'm going to just say that we've got that minus 48x as well. And then for the last part, I have the r squared, the minus 24r, and the 144 is equal to 0. So it just needs a bit of factorising in that middle section. Let's make it in the form that they want. Plus 2r minus 48x plus r squared minus 24r plus 144 is equal to 0. Now, if you couldn't do part A, you can still do part B. Given also that L is a tangent to C, find the two possible values of r, giving your answers as fully simplified surds. So if it's a tangent, that means that this equation here, the discriminant, b squared minus 4ac, is equal to 0. So we're going to perform the discriminant on this thing that we have for part B of the question. The a is 5, the b is 2r minus 48, and the c is r squared minus 24r plus 144. We're going to work out what b squared minus 4ac is, and then we're going to make it equal to 0. So we're going to do 2r minus 48 squared minus 4 times a times r squared minus 24r plus 144, and we're going to make that equal 0. So from the 2r minus 48, you're going to get 4r squared, and then you're going to get 2 times 48, 2 of them. 2 times 48, 2 of them, which is 192r. And then we get, just as if you weren't expecting it, a 48 squared, which is 2,304. We've then got minus 20 of these things, r squared minus 24r plus 144. So that's 4r squared minus 192r plus 2,304 minus 20r squared plus 480r, and then that's going to be minus 2880. You could have done that on your calculator, but here we go. So now I'm going to simplify. I've got 4 minus 20, that's minus 16r squared. I've then got minus 192 plus 480. So I'm going to do minus 192 plus 480. That is plus 288r. And then I've got 2,304 minus 2880. 2,304, did I say minus? Minus 2,880, which is minus 576. So I'm now going to go to my polynomial solver on my calculator. I'm going to put the coefficients of minus 16, 288, and minus 576. And it gives me that my solutions for r are 9 plus or minus 3 root 5. And those are the two solutions that it was looking for, two possible values of r, giving your answer as fully simplified surds that we have here. So I was able to do that last bit just by putting it on the calculator. We have got 2 questions to go. We have got 15 and then 16. I actually think 15 is not that bad, but you do need to know the proof of this thing. So it says a geometric series has common ratio r and first term a, and it wants us to prove this formula that we've got here. It also says that r is not equal to 1. So to prove this, we write down what the sum to n is. It's going to be a plus ar plus ar squared, and then you have plus ar to the n minus 2 plus ar to the n minus 1. Now I'm going to take this same one and I'm going to multiply everything by r, and I'm also going to just shift it along. So I'm going to shift that along one space. So I'm going to multiply that by r, I multiply that by r. When I multiply this one previously by r, I would get this, and when I multiply this one by r, I get this, and my last one that I would get by multiplying that by r is ar to the n. So when I do, everything here has been multiplied by r and I've kind of shifted it along one space. This one's come from the dotted part and that one's gone into the dotted part. If I do the second one minus the first one, if I do rsn minus sn, I would get this take away this take away this take away this take away this. All of that middle section is going to completely disappear. So I just get left with the ar to the n minus the a that we have from the very beginning, because that one's going to get subtracted there. I'm then going to factorise on this left-hand side, and I'm also going to factorise over here, so that I get the sum to n is a brackets Rn minus 1 over r minus 1. And if I multiply the top and bottom by minus 1, if I negate the top and bottom, I mean, look, if you're on this question, you must know what I mean when I say negating. You get a brackets 1 minus r to the n over 1 minus r, which is what we wanted to prove. They've asked about the arithmetic one recently as well, so it's definitely worth knowing the proofs, seeing as they've started throwing these in here, and I do cover them in my playlists. Given also that S10 is 4 times S5, find the exact value of R. Okay, so they have said that S10 is 4 times the value of S5. Weirdly, when people do this, I always see people do 4S10 is S5. That's completely wrong. It says S10 is 4 times the value of S5, so this is what your equation should look like. So S10, I'm just going to use this formula you've got here, and if you couldn't do part A, you can definitely do part B. It is going to be a brackets 1 minus r to the 10 over 1 minus r equals 4 multiplied by S5, which is going to be a 1 minus r to the 5 over 1 minus r. Now I can cancel out 1 minus r on both sides and a on both sides, so that I get 1 minus r to the 10 is 4 times by 1 minus r to the 5, which is 4 minus 4r to the 5. Now, this looks kind of tricky. I'm going to get it onto one side. I'm actually going to put everything onto the right-hand side. So I get r to the power of 10 minus 4r to the power of 5 plus 3. This is the part you need to spot. This is what I call an example of a pseudo-quadratic. It looks a bit like a quadratic, even though it actually isn't one. It's actually a quadratic in r to the power of 5. So you can either just go straight in with your calculator, or you can do, sometimes people do this technique. You can say, let y equal r to the power of 5. That means that y squared is r to the power of 10. So it is y squared minus 4y plus 3. You can use your equation solver to do this. So I'm just going to say that it's 2 degrees. Obviously, it factorizes really nicely. So you get that y is equal to 3 or y is equal to 1. But remember we said that this was true. Sorry, we said that this was true. So this means that r to the power of 5 is equal to 3 or r to the power of 5 is equal to 1. Well, that must mean that r is equal to 1, but they've said that r cannot be equal to 1, so we won't include that. So r is going to be equal to the 5th root of 3. And I'm guessing they want that in its exact form. Yeah, they want it in its exact form. So you could either say the 5th root of 3, or you could say 3 to the power of a 5th. I think I personally just prefer writing it as the 5th root of 3. And then we're finally on to the last question, which is a proof question. They seem to like ending with proof. And actually these ones can be a bit more accessible than usually the 15 and 14 questions. So it says, use algebra to prove that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. Now it's weird that this is multiple of 3, because how are you going to get the 3ness from just like a normal natural number? So the way that we do this is we're going to do an example of proof by exhaustion, which is how I feel at the end of this paper. We're going to do proof by exhaustion, which means normally you used to do like test the even numbers and then test the odd numbers, but we're not going to do that. What we're going to test instead is we're going to test the multiples of 3. We're going to test the multiples of 3 plus 1, and we're going to do the multiples of 3. You can either do plus 2, or you can do the multiples of 3 minus 1. Because if you think about all numbers, I don't know, like 5, 6, 7, 8, 9, 10, 11, 12, they are either multiples of 3, they are the multiples of 3 plus 1, or they're the multiples of 3 minus 1. That covers and exhausts all of the numbers that exist. So we're going to do this by saying that the multiples of 3, let me just get this out of the way for a second. The multiples of 3 we're just going to say are like, I don't know, 3k. The multiples of 3 plus 1 and the multiples of 3 minus 1. We're going to find the square of those numbers and see what happens. So for 3k squared is 9k squared. We want to show that it's either a multiple of 3. Well, this is a multiple of 3. So this is a multiple of 3. We're going to do the same thing with our 3k plus 1. That's going to be a 9k squared plus 3k, which is plus 6k, plus 1. Now we want to show that this is 1 more than a multiple of 3. If I take a factor of 3 out of the beginning, I get 3k squared plus 2k plus 1. So this is 1 more than a multiple of 3. This is 1 more than a multiple of 3. And we're going to do the last one, which is 3k minus 1 squared, which is 9k squared minus 6k minus 1, which is 3 brackets 3k squared minus 2k. Oops, sorry, it's a plus 1, isn't it? Plus 1. So this is 1 more than a multiple of 3. Hence, let's get the right wording. Hence, the square of any natural number. Natural numbers are just like the counting numbers, like 1, 2, 3, 4, 5 integers. Hence, the square of any natural number is either a multiple of 3 or 1 more than a multiple of 3. And I think the tricky thing here is that recognizing the 3-ness of this question means you can't split it into even and odd. We instead have to split it into these things that we've got over here, the multiples of 3, 1 more than multiple of 3 and 1 less than multiple of 3. And it's kind of cool. You can just think about it with like any number that you do. If you square it, it's either in the 3 times table or it's 1 more than the 3 times table. It's a pretty cool thing to have noticed. Now I think this is probably the hardest paper I've seen in ages. Maybe it's just because I'm tired, but I think this paper is I think it's really, really tough. I can imagine people who came out of that exam, even though it was sat as like after the pandemic, I imagine people were really stressed by that. I'm hoping that the exam coming up this year is going to be a little bit easier, but if you can do some of these things, remember, like I said at the beginning, you're aiming to get, depending on what grade you want, you're not aiming to get all of the marks, okay? You're aiming to get some of the marks that you need to get the grade for wherever you want to go next or whatever grade you're aiming for. So I'm wishing you all the best with all your studies. You must be working really hard, and I just hope you get the best grade that you can do. Good luck.